Today we are discussing about the work that is in thermodynamic property. According to the physics, work is said to have been done whenever the point of application of a force is displaced in the direction of the force. So we can represent the work as W is equal to F into dl. Here F represents for the magnitude of force and dl represents the displacement. So according to this definition, work is a mechanical work. We can also give a generalized definition for the work is the work done is equal to a generalized force into a generalized displacement. When we discuss about the thermodynamics, two main type of work, two main types of work used in thermodynamics. First one is electrical work. In the case of electrical work, the generalized force is EMF and generalized displacement is quantity of the electricity flowing through the circuit. So the electrical work will be, what is the generalized force? That is an EMF into the generalized displacement means the quantity of electricity. So this is the formula for electrical work, means work is the force into displacement. So here for the electrical work, force will be EMF and displacement is the quantity of electricity which is flowing through the circuit. Second category or second type of work is work of expansion or work of compression. If we took a gas in a jar, if we expand, there will be, if we put some pressure on that jar, there will be compression of the gas. That is a type of work. And if we keep the frictionless piston, the gas expand. That is also an work. So the second category of work is the expansion and compression. We can also say that it is the pressure volume work. We will study this in cases of gases. It is the work done when the gas expands or contracts against the atmospheric pressure. We can also say that it is a kind of mechanical work. For example, if we take a beaker or a jar and we keep a frictionless piston on this jar, when we apply some pressure, at that time compression occurs. The gas will be compressed. First, we consider this is a jar which is have an area A, that is an area, and this is the frictionless piston. When we apply some pressure P which is more than the atmospheric pressure to the piston, there will be compression of gas takes place, and this is the displacement of the piston. So it is denoted by the dl. Here we can say that area of cross section of the cylinder or a jar is equal to A square centimeter. Pressure of piston is P, and the distance through which gas expands is dl centimeter. So if we calculate the pressure, or what is the pressure? Pressure is a force per unit area. We all know pressure is force per unit area, means F is equal to P into A. We can also say that about the force. So we all know work done. If we calculate the work done by the gas is W, that is equal to the force into distance. So work will be, what will be the force? We can put the value of force from here, that is the P into A into what is the distance? Distance is dl. So we put the value of distance, that is the dl. As we know, there is the distance in a particular area, that is the dl into A will be the change in the distance in a particular area is known as the change in the volume. So dl into A will be dV, means the change in the volume. So if we calculate the small work done by the gas will be del W, that is del is for the small work. So del W is equal to P, and A into dl, we will put the value of A into dl, that will be change in the volume. So del W is equal to P dV. If we consider that if the gas expand from initial volume V1 to the final volume, that is V2, so what will be the total work? We should calculate the total work done is equal to W is equal to integration V2 V1 to V2 P dV. If the gas expand against constant external pressure, or we can say that it is an irreversible expansion, at that time the work will be P is constant, so it comes out, so P V1 to V2 dV. We solve this. V is equal to P V2 minus V1. Here V2 minus V1 is the change in volume, so we can also represent it by the delta V. If the external pressure P is slightly more than the pressure of gas, the gas will contract. or compressed. So, for external pressure, we can represent the external pressure as the P ext. We can write that P external pressure. So, work will be W is equal to P external delta V. It is only for the case in where the external pressure is more than the pressure of the gas. Now, sign of the work. The work means the W is positive in the case where work is done on the system. Or we can say that in the case of compression. When we compress a gas, there will be work is done on the system. If the value of W is or work is negative, that means work is done by the system. That means expansion. Now we will discuss about the units of work. In CGS unit, the unit of work will be the erg, and in SI unit, the unit will be joules. We know that the relation between the erg and joule is equal to 1 joule is equal to 10 to the power 7 ergs. Two important points about the work, that work is a path function, means it is not a state function, it is a path function. It is depend on the route on which it followed. And work is an extensive property. That means it depends upon the quantity of system.